Hey guys, we're on our last section of Chapter 5, and this one is on describing number patterns. The objective is to use inductive reasoning in continuing number patterns and to write rules for arithmetic sequences. So let's go through. We'll start, first of all, this is a typo here. This should be inductive, not indictive, but inductive reasoning and number patterns. And inductive reasoning is making conclusions based on patterns you observe. So this is inductive reasoning. And a conclusion you reach by inductive reasoning is a conjecture. Okay. So the first part, you guys have all probably done this before, but it says use inductive reasoning to describe each pattern. Then find the next two numbers in each pattern. So if you look at A, that's 3, 9, 27, 81. And so when I look at this, I can see that the pattern is multiplying by 3. So 81 times 3 is 243. And 243 times 3 is 729. If you look at part B, it goes 9, 15, 21, and 27. So let's see. Oh, this one is adding 6 each time. So if I take 27 and add 6, I'm going to get 33. And then if I add 6 more, I'm going to get 39. And then this next one, I have 2, negative 4, 8, negative 16. Because it's positive, negative, I can kind of think about I'm probably multiplying by a negative number. And so I'm multiplying by a negative 2 here each time. So negative 16 times negative 2 is going to be a positive 32. And then 32 times negative 2 is going to give me a negative 64. I don't know what this is right here. So this next part is writing rules for arithmetic sequences. And so a number pattern is called a sequence. It's a sequence of numbers. And then each number in a sequence is a term of the sequence. The first type of sequence we're going to talk about in this chapter is called an arithmetic. So you form an arithmetic sequence by adding a fixed number. So the biggest thing here is we're adding a fixed number to each previous term. The fixed number is the common difference. I don't know if you can see that thing on my screen, but I don't know how to get rid of it. So, common difference. So the first part says find the common difference. So remember, it's whatever we're adding to it. So if you look at this one right here, we're adding 12 each time. So the common difference is a positive 12. This next one, if you notice, it's going down by 5, but we have to think about this as adding a negative 5 because an arithmetic sequence by adding a fixed number. And so we're adding a negative 5, which means the common difference is a negative 5. And here's a rule for arithmetic sequence. So let's just kind of go through and label this rule first of all. N is the number term it is. So is it the first term in the sequence, the second term in the sequence? If I can spell term correctly. Where's my eraser? Okay. What A stands for here, this lowercase a, this is the first term. So whatever the first term is in the sequence. And then this n is the same as the n over here. It's the number term of the sequence. And then this d is the common difference. So what is it? What is being added to it every single time? Okay, so this is written in function notation, so a to the n A of n equals A plus n minus 1 times D. So let's look at one of these examples. So it says finding terms of the sequence. It says find the first, 6th, and 12th terms of the sequence. And so as I look through here, first of all, I just want to point something out. This 5 right here is the first term of the sequence. This 3 right here is the common difference. Okay, so those are a couple things that I just want you to kind of pay attention to as we go through. Oops. So, first of all, I said what was the first? Well, we can find the first just by looking at this. It's -5. To find the 6th term, what we're going to do is we're going to substitute 6 in for n. So 6 minus 1 times 3, and then from here we're just going to use our order of operations. So remember, this isn't a times 6, this is a of 6. It's the function of 6. Is -5 plus, we need to do what's in parentheses first. 6 minus 1 is 5 times 3. From here we're going to multiply, so then it ends up being -5 plus 15. And so then if I add those together, it's going to be 10. So that tells me that the 6th term is a positive 10. And we're going to do the same exact thing for the 12th term, except for we're just going to substitute in a 12 for n instead of the 6. So a of 12 is -5 plus 11 times 3. We have to multiply first with -5 plus 33. So the function of 12, if I add these together, I'm going to get 28. And so the 12th term of the sequence is 28. And that's it. So arithmetic sequence is when you add something, and whatever you're adding to it is your common difference. And then being able to recognize number patterns up there. So there we have it. See you guys tomorrow.